Morse code is a method of transmitting text information as a series of on-off tones, lights, or clicks that can be directly understood by a skilled listener or observer without special equipment. The International Morse code encodes the ISO basic Latin alphabet, some extra Latin letters, the Arabic numerals and a small set of punctuation and procedural signals as standardized sequences of short and long signals called dots, and dashes, or dits, and Rs. Because many non-English natural languages use more than the 26 Roman letters, extensions to the Morse alphabet exist for those languages. Each character is represented by a unique sequence of dots and dashes. The duration of a dash is 3 times the duration of a dot. Each dot or dash is followed by a short silence, equal to the dot duration. The letters of a word are separated by a space equal to 3 dots, and the words are separated by a space equal to 7 dots. The dot duration is the basic unit of time measurement in code transmission. For efficiency, the length of each character in Morse is approximately inversely proportional to its frequency of occurrence in English. Thus, the most common letter in English, the letter E, has the shortest code, a single dot. Morse code is most popular among amateur radio operators, although it is no longer required for licensing in most countries. Pilots and air traffic controllers usually need only a cursory understanding. Aeronautical navigational aids, such as VORs and NDBs, constantly identify in Morse code. Compared to voice, Morse code is less sensitive to poor signal conditions, yet still comprehensible to humans without a decoding device. Morse is therefore a useful alternative to synthesized speech for sending automated data to skilled listeners on voice channels. Many amateur radio repeaters, for example, identify with Morse, even though they are used for voice communications. For emergency signals, Morse code can be sent by way of improvised sources that can be easily keyed on and off, making it one of the simplest and most versatile methods of telecommunication. The most common distress signal is SOS or 3 dots, 3 dashes and 3 dots, internationally recognized by treaty. Development and history. Beginning in 1836, the American artist Samuel F. B. Morse, the American physicist Joseph Henry, and Alfred Vail developed an electrical telegraph system. This system sent pulses of electric current along wires which controlled an electromagnet that was located at the receiving end of the telegraph system. A code was needed to transmit natural language using only these pulses, and the silence between them. Morse therefore developed the forerunner to modern International Morse code. In 1837, William Cooke and Charles Wheatstone in England began using an electrical telegraph that also used electromagnets in its receivers. However, in contrast with any system of making sounds of clicks, their system used pointing needles that rotated above alphabetical charts to indicate the letters that were being sent. In 1841, Cooke and Wheatstone built a telegraph that printed the letters from a wheel of typefaces struck by a hammer. This machine was based on their 1840 telegraph and worked well. However, they failed to find customers for this system and only 2 examples were ever built. On the other hand, the 3 Americans system for telegraphy, which was first used in about 1844, was designed to make indentations on a paper tape when electric currents were received. Morse's original telegraph receiver used a mechanical clockwork to move a paper tape. When an electrical current was received, an electromagnet engaged an armature that pushed a stylus onto the moving paper tape, making an indentation on the tape. When the current was interrupted, a spring retracted the stylus, and that portion of the moving tape remained unmarked. The Morse code was developed so that operators could translate the indentations marked on the paper tape into text messages. In his earliest code, Morse had planned to only transmit numerals, and use a dictionary to look up each word according to the number which had been sent. However, the code was soon expanded by Alfred Vail to include letters and special characters, so it could be used more generally. Vail determined the frequency of use of letters in the English language by counting the movable type he found in the type cases of a local newspaper in Morristown. The shorter marks were called dots, and the longer ones dashes, and the letters most commonly used were assigned the shorter sequences of dots and dashes. In the original Morse telegraphs, the receiver's armature made a clicking noise as it moved in and out of position to mark the paper tape. The telegraph operators soon learned that they could translate the clicks directly into dots and dashes, and write these down by hand, thus making the paper tape unnecessary. When Morse code was adapted to radio communication, the dots and dashes were sent as short and long pulses. It was later found that people became more proficient at receiving Morse code when it is taught as a language that is heard, instead of one read from a page. To reflect the sounds of Morse code receivers, the operators began to vocalize a dot as dit, and a dash as dash. Dots which are not the final element of a character became vocalized as d. For example, the letter C was then vocalized as daddy dadit. In the 1890s, Morse code began to be used extensively for early radio communication, before it was possible to transmit voice. In the late 19th and early 20th century, most high-speed international communication used Morse code on telegraph lines, undersea cables and radio circuits. In aviation, Morse code in radio systems started to be used on a regular basis in the 1920s. Although previous transmitters were bulky and the spark gap system of transmission was difficult to use, there had been some earlier attempts. In 1910 the U.S. Navy experimented with sending Morse from an airplane. That same year a radio on the airship America had been instrumental in coordinating the rescue of its crew. Zeppelin airships equipped with radio were used for bombing and naval scouting during World War I, and ground-based radio direction finders were used for airship navigation. Allied airships and military aircraft also made some use of radio telegraphy. However, there was little aeronautical radio in general use during World War I, and in the 1920s there was no radio system used by such important flights as that of Charles Lindbergh from New York to Paris in 1927. Once he and the Spirit of St. Louis were off the ground, Lindbergh was truly alone and incommunicado. On the other hand, when the first airplane flight was made from California to Australia in the 1930s on the Southern Cross, one of its 4 crewmen was its radio operator who communicated with ground stations via radio telegraph. Beginning in the 1930s, both civilian and military pilots were required to be able to use Morse code, both for use with early communications systems and identification of navigational beacons which transmitted continuous 2- or 3-letter identifiers in Morse code. Aeronautical charts show the identifier of each navigational aid next to its location on the map. Radio telegraphy using Morse code was vital during World War II, especially in carrying messages between the warships and the naval bases of the belligerents. Long-range ship-to-ship communications was by radio telegraphy, using encrypted messages, because the voice radio systems on ships then were quite limited in both their range and their security. Radio telegraphy was also extensively used by warplanes, especially by long-range patrol planes that were sent out by these navies to scout for enemy warships, cargo ships, and troop ships. In addition, rapidly moving armies in the field could not have fought effectively without radio telegraphy, because they moved more rapidly than telegraph and telephone lines could be erected. This was seen especially in the blitzkrieg offensives of the Nazi German Wehrmacht in Poland, Belgium, France, the Soviet Union, and in North Africa. By the British Army in North Africa, Italy, and the Netherlands. And by the U.S. Army in France and Belgium, and in southern Germany in 1945. Morse code was used as an international standard for maritime distress until 1999, when it was replaced by the Global Maritime Distress Safety System. When the French Navy ceased using Morse code on January 31, 1997, the final message transmitted was calling all. This is our last cry before our eternal silence. In the United States the final commercial Morse code transmission was on July 12, 1999, signing off with Samuel Morse's original 1844 message, "What hath God wrought," and the Prozine SK. The United States Coast Guard has ceased all use of Morse code on the radio, and no longer monitors any radio frequencies for Morse code transmissions, including the international medium frequency distress frequency of 500 kHz. However, the Federal Communications Commission still grants commercial radio telegraph operator licenses to applicants who pass its code and written tests. Licensees have reactivated the old California Coastal Morse station KPH and regularly transmit from the site under either this call sign or as KSM. Similarly, a few U.S. museum ship stations are operated by Morse enthusiasts. User proficiency. Morse code speed is measured in words per minute or characters per minute. Characters have differing lengths because they contain differing numbers of dots and dashes. Consequently, words also have different lengths in terms of dot duration, even when they contain the same number of characters. For this reason, a standard word is helpful to measure operator transmission speed. Paris and codex are two such standard words. Operators skilled in Morse code can often understand code in their heads at rates in excess of 40 WPM. International contests in code copying are still occasionally held. In July 1939 at a contest in Asheville, North Carolina in the United States, Ted R. McElroy set a still-standing record for Morse copying, 75.2 WPM. William P. Ponten OHFF also notes that some operators may have passed 100 WPM. By this time they are hearing phrases and sentences rather than words. The fastest speed ever sent by a straight key was achieved in 1942 by Harry Turner W9YZE, who reached 35 WPM in a demonstration at a U.S. Army base. To accurately compare code copying speed records of different eras, it is useful to keep in mind that different standard words and different interword gaps may have been used when determining such speed records. For example, speeds run with the Codex standard word and the Paris standard may differ by up to 20%. Today, among amateur operators there are several organizations that recognize high-speed code ability, one group consisting of those who can copy Morse at 60 WPM. Also, certificates of code proficiency are issued by several amateur radio societies, including the American Radio Relay League. Their basic award starts at 10 WPM with endorsement as high as 40 WPM, and are available to anyone who can copy the transmitted text. Members of the Boy Scouts of America may put a Morse interpreter's strip on their uniforms if they meet the standards for translating code at 5 WPM. International Morse code has been in use for more than 160 years, a euro longer than any other electrical coding system. What is called Morse code today is actually somewhat different from what was originally developed by Vail and Morse. The modern International Morse code, or Continental code, was created by Friedrich Clemens Goerke in 1848 and initially used for telegraphy between Hamburg and Cuxhaven in Germany. Goerke changed nearly half of the alphabet and all of the numerals, resulting substantially in the modern form of the code. After some minor changes, International Morse code was standardized at the International Telegraphy Congress in 1865 in Paris, and was later made the standard by the International Telecommunication Union. Morse's original code specification, largely limited to use in the United States and Canada, became known as American Morse code or Railroad code. American Morse code is now seldom used except in historical reenactments. Aviation. In aviation, instrument pilots use radio navigation aids. To ensure that the stations the pilots are using are serviceable, the stations all transmit a short set of identification letters in Morse code. Station identification letters are shown on air navigation charts. For example, the VO based at Manchester Airport in England is abbreviated as MCT, and MCT in Morse code is transmitted on its radio frequency. In some countries, during periods of maintenance, the facility may radiate a TEST code or the code may be removed, which tells pilots and navigators that the station is unreliable. In Canada, the identification is removed entirely to signify the navigation aid is not to be used. In the aviation service, Morse is typically sent at a very slow speed. In the U.S., this is about 5 words per minute. Pilots do not actually have to know Morse to identify the transmitter because on aeronautical charts, the sound sequences are written out next to the transmitter's symbol. Some modern navigation receivers automatically translate the code into displayed letters. Amateur radio. International Morse code today is most popular among amateur radio operators, where it is used as the pattern to key a transmitter on and off in the radio communications mode commonly referred to as continuous wave, or CW, to distinguish it from spark transmissions, not because the transmission was continuous. Other keying methods are available in radio telegraphy, such as frequency shift keying. The original amateur radio operators used Morse code exclusively, since voice-capable radio transmitters did not become commonly available until around 1920. Until 2003, the International Telecommunication Union mandated Morse code proficiency as part of the amateur radio licensing procedure worldwide. However, the World Radio Communication Conference of 2003 made the Morse code requirement for amateur radio licensing optional. Many countries subsequently removed the Morse requirement from their license requirements. Until 1991, a demonstration of the ability to send and receive Morse code at a minimum of 5 words per minute was required to receive an amateur radio license for use in the United States from the Federal Communications Commission. Demonstration of this ability was still required for the privilege to use the HF bands. Until 2000, proficiency at the 20 WPM level was required to receive the highest level of amateur license. Effective April 15, 2000, the FCC reduced the extra class requirement to 5 WPM. Finally, effective on February 23, 2007, the FCC eliminated the Morse code proficiency requirements from all amateur radio licenses. While voice and data transmissions are limited to specific amateur radio bands under U.S. rules, Morse code is permitted on all amateur bands, so LF, MF, HF, UHF, and VHF. In some countries, certain portions of the amateur radio bands are reserved for transmission of Morse code signals only. The relatively limited speed at which Morse code can be sent led to the development of an extensive number of abbreviations to speed communication. These include prosigns, Q codes, and a set of Morse code abbreviations for typical message components. For example, CQ is broadcast to be interpreted as CQ. OM, YL and XYL are common abbreviations. YL or OM is used by an operator when referring to the other operator, XYL or OM is used by an operator when referring to his or her spouse. QTH is location. The use of abbreviations for common terms permits conversation even when the operators speak different languages. Although the traditional telegraph key is still used by some amateurs, the use of mechanical semi-automatic keyers and a fully automatic electronic keyers is prevalent today. Software is also frequently employed to produce and decode Morse code radio signals. Other uses. Through May 2013, the first, second, and third-class radio telegraph licenses using code tests based upon the codex standard word were still being issued in the United States by the Federal Communications Commission. The first-class license required 20 WPM code group and 25 WPM text code proficiency, the others 16 WPM code group test and 20 WPM code text test. It was also necessary to pass written tests on operating practice and electronics theory. A unique additional demand for the first class was a requirement of a year of experience for operators of shipboard and coast stations using Morse. This allowed the holder to be chief operator on board a passenger ship. However, since 1999, the use of satellite and very high-frequency maritime communications systems has made them obsolete. Currently only one class of license, the Radio Telegraph Operator Certificate, is issued. This is granted either when the tests are passed or as the second and first are renewed and become this lifetime license. For new applicants, it requires passing a written examination on electronic theory, as well as 16 WPM code and 20 WPM text tests. However, the code exams are currently waived for holders of amateur extra-class licenses who obtain their operating privileges under the old 20 WPM test requirement. Radio navigation aids such as VORs and NDBs for aeronautical use broadcast identifying information in the form of Morse code, though many VOR stations now also provide voice identification. Warships, including those of the U.S. Navy, have long used signal lamps to exchange messages in Morse code. modern use continues, in part, as a way to communicate while maintaining radio silence. Submarine periscopes include a signal lamp. Applications for the general public. An important application is signaling for help through SOS, AAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAAA. Mirror, toggling a flashlight and similar methods. SOS is not three separate characters, rather, it is a precise SOS, and is keyed without gaps between characters. Morse code as an assistive technology. Morse code has been employed as an assistive technology, helping people with a variety of disabilities to communicate. Morse can be sent by persons with severe motion disabilities, as long as they have some minimal motor control. An original solution to the problem that caretakers have to learn to decode has been an electronic typewriter with the codes written on the keys. Codes were sung by users. See the voice typewriter employing Morse or Votum, Newell and Nabarro, 1968. Morse code can also be translated by computer and used in a speaking communication aid. In some cases this means alternately blowing into and sucking on a plastic tube. An important advantage of Morse code over row column scanning is that, once learned, it does not require looking at a display. Also, it appears faster than scanning. People with severe motion disabilities in addition to sensory disabilities can receive Morse through a skin buzzer, in one case reported in the radio amateur magazine QST. An old shipboard radio operator who had a stroke and lost the ability to speak or write could communicate with his physician by blinking his eyes in Morse. Another example occurred in 1966 when prisoner of war Jeremiah Denton, brought on television by his North Vietnamese captors, Morse blinked the word torture. In these two cases interpreters were available to understand those series of eye blinks. Representation, timing and speeds. International Morse code is composed of 5 elements: short mark, dot or dit euro dot duration is 1 time unit long, longer mark, dash or dow euro 3 time units long, inter-element gap between the dots and dashes within a character euro 1 dot duration or 1 unit long, short gap euro 3 time units long, medium gap euro 7 time units long. Morse code can be transmitted in a number of ways, originally as electrical pulses along a telegraph wire, but also as an audio tone, a radio signal, with short and long tones, or as a mechanical, audible or visual signal using devices like an Ordis lamp or a heliograph, a common flashlight, or even a car horn. Some mine rescues have used pulling on a rope, a short pull for a dot and a long pull for a dash. Morse code is transmitted using just 2 states. Historians have called it the first digital code. Strictly speaking, it is not binary, as there are 5 fundamental elements. However, this does not mean Morse code cannot be represented as a binary code. In an abstract sense, this is the function that telegraph operators perform when transmitting messages. Working from the above definitions and further defining a unit as a bit, we can visualize any Morse code sequence as a combination of the following 5 elements: short mark, dot or dit euro 1, longer mark, dash or dow euro 111, intra-character gap euro 0, short gap euro 000, medium gap euro 0000000. Note that this method assumes that dits and dars are always separated by dot duration gaps, and that gaps are always separated by dits and dars. Morse messages are generally transmitted by a hand-operated device such as a telegraph key, so there are variations introduced by the skill of the sender and receiver. More experienced operators can send and receive at faster speeds. In addition, individual operators differ slightly, for example using slightly longer or shorter dashes or gaps, perhaps only for particular characters. This is called their fist, and experienced operators can recognize specific individuals by it alone. A good operator who sends clearly and is easy to copy is said to have a good fist. A poor fist is a characteristic of sloppy or hard-to-copy Morse code. An operator must choose 2 speeds when sending a message in Morse code. First, the operator must choose the character speed, or how fast each individual letter is sent. Second, the operator must choose the text speed, or how fast the entire message is sent. Both speeds can be the same, but often they are not the same. An operator could generate the characters at a high rate, but by increasing the space between the letters, send the message more slowly. Using different character and text speeds is, in fact, a common practice, and is used in the Farnsworth method of learning Morse code. Because Morse code is usually hand-generated, an operator may retain a certain comfortable character speed, but vary the text speed by varying the spacing between the letters. All Morse code elements depend on the dot length. A dash is the length of 3 dots, and spacings are specified in number of dot lengths. Because of this, some method to standardize the dot length is useful. A simple way to do this is to send the same 5-character word over and over for 1 minute at a speed that will allow the operator to send the correct number of words in 1 minute. If, for example, the operator wanted a character speed of 13 words per minute, the operator would send the 5-character word 13 times in exactly 1 minute. From this, the operator would arrive at a dot length necessary to produce 13 words per minute while meeting all the standards. The word one chooses determines the dot length. A word with more dots, like Paris, would be sent with longer dots to fill in 1 minute. A word with more dashes, like codex, would produce a shorter dot length so everything would fit into 1 minute. The words Paris and codex are frequently used as a Morse code standard word. Using the word Paris as a standard, the number of dot units is 50 and a simple calculation shows that the dot length at 20 words per minute is 60 milliseconds. Using the word codex with 60 dot units, the dot length at 20 words per minute is 50 milliseconds. Because Morse code is usually sent by hand, it is unlikely that an operator could be that precise with the dot length, and the individual characteristics and preferences of the operators usually override the standards. For commercial radio telegraph licenses in the United States, the Federal Communications Commission specifies tests for Morse code proficiency in words per minute of text speed. The Commission does not specify character speeds. For proficiency at 20 words per minute, it would be impossible to generate characters at less than that speed. If, for example, the characters were generated at a rate to produce 5 words in 1 minute, the examiner could not send 20 words in 1 minute. Conversely, the examiner could generate characters at a rate to produce 24 words per minute, but increase the character spacing to send the message at 20 words per minute. The regulation, however, only specifies the number of words to be received in 1 minute. While the Federal Communications Commission no longer requires Morse code for amateur radio licenses, the old requirements were similar to the requirements for commercial radio telegraph licenses. There was no requirement for any particular character speed, but the examinee had to send and receive a message at a specified text speed. A difference between amateur radio licenses and commercial radio telegraph licenses is that commercial operators must be able to receive code groups of random characters along with plain language text. For each class of license, the code group speed requirement is slower than the plain language text requirement. For example, for the radio telegraph operator license, the examinee must pass a 20-word per minute plain text test and a 16-word per minute code group test. Based upon a 50-dot duration standard word such as Paris, the time for 1 dot duration or 1 unit can be computed by the formula, T equals 1200 per watt, or T equals 6000 per carat, where T is the unit time, or dot duration, in milliseconds, W is the speed in WPM, and C is the speed in CPM. Below is an illustration of timing conventions. The phrase Morse code, in Morse code format, would normally be written something like this, where a euro represents DAS and a represents DITS. MORSECODE. Next is the exact conventional timing for this phrase, with equals representing signal on, and representing signal off, each for the time length of exactly 1 dit. Morse code is often spoken or written with DA for dashes, DIT for dots located at the end of a character, and D for dots located at the beginning or internally within the character. Thus, the following Morse code sequence: MORSECODE, is orally da 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 dee da dit dee dee dit dit, da dee da dit da 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 dee dit dit. Note that there is little point in learning to read written Morse as above. Rather, the sounds of all of the letters and symbols need to be learned, for both sending and receiving. Link budget issues. Morse code cannot be treated as a classical radio teletype signal when it comes to calculating a link margin or a link budget for the simple reason of it possessing variable length dots and dashes as well as variant timing between letters and words. For the purposes of information theory and channel coding comparisons, the word Paris is used to determine Morse code's properties because it has an even number of dots and dashes. Morse code when transmitted essentially creates an AM signal. Assumptions about signal can be made with respect to similarly timed RTTY signaling. Because Morse code transmissions employ an on-off keyed radio signal, it requires less complex transmission equipment than other forms of radio communication. Morse code also requires less signal bandwidth than voice communication, typically 100–150 Hz, compared to the roughly 2400 Hz used by single-sideband voice, although at a lower data rate. Morse code is usually received as a medium-pitched audio tone, so transmissions are easier to copy than voice through the noise on congested frequencies, and it can be used in very high noise/low signal environments. The transmitted power is concentrated into a limited bandwidth so narrow receiver filters can be used to suppress interference from adjacent frequencies. The narrow signal bandwidth also takes advantage of the natural aural selectivity of the human brain, further enhancing weak signal readability. This efficiency makes CW extremely useful for DX transmissions, as well as for low-power transmissions. The ARRL has a readability standard for robot encoders called ARRL Farnsworth spacing that is supposed to have higher readability for both robot and human decoders. Some programs like WinMorse have implemented the standard. Learning methods. People learning Morse code using the Farnsworth method are taught to send and receive letters and other symbols at their full target speed, that is with normal relative timing of the dots, dashes and spaces within each symbol for that speed. The Farnsworth method is named for Donald R. Russ Farnsworth, also known by his call sign, W6TTB. However, initially exaggerated spaces between symbols and words are used, to give thinking time to make the sound shape of the letters and symbols easier to learn. The spacing can then be reduced with practice and familiarity. Another popular teaching method is the Koch Method, named after German psychologist Ludwig Koch, which uses the full target speed from the outset, but begins with just 2 characters. Once strings containing those 2 characters can be copied with 90% accuracy, an additional character is added, and so on until the full character set is mastered. In North America, many thousands of individuals have increased their code recognition speed by listening to the regularly scheduled code practice transmissions broadcast by W1AW, the American Radio Relay League's headquarters station. In the United Kingdom, many people learned the Morse code by means of a series of words or phrases that have the same rhythm as a Morse character. For instance, Q in Morse is da-da-dee-da, which can be memorized by the phrase God Save the Queen, and the Morse for F is dee-dee-da-dit, which can be memorized as Did You Like It? A well-known Morse code rhythm from the Second World War period derives from Beethoven's Fifth Symphony, the opening phrase of which was regularly played at the beginning of BBC broadcasts. The timing of the notes corresponds to the Morse for V. D-D-D-da stood for V for victory. Letters, numbers, punctuation, prosigns and non-English variants, symbol representations, the and, dollar and signs are not defined inside the ITU recommendation on Morse code. Exclamation mark. There is no standard representation for the exclamation mark, although the KW digraph was proposed in the 1980s by the Heathkit Company. While Morse code translation software prefers the Heathkit version, on-air use is not yet universal as some amateur radio operators in North America and the Caribbean continue to prefer the older MN digraph carried over from American landline telegraphy code. Currency symbols. The ITU has never codified formal Morse code representations for currencies, as the ISO 4217 currency codes are preferred for transmission. The $sign code was represented in the Phillips code, a huge collection of abbreviations used on landline telegraphy, as SX. Ampersand, the representation of the sign given above, often shown as AS, is also the Morse sign for wait. In addition, the American landline representation of an ampersand was similar to ES, and hams have carried over this usage as a synonym for and. Keyboard AT on May 24, 2004, the 160th anniversary of the first public Morse telegraph transmission, the Radio Communication Bureau of the International Telecommunication Union formally added the A character to the official Morse character set, using the sequence denoted by the AC digraph. This sequence was reportedly chosen to represent a, T, C, commercial, or a letter A inside a swirl represented by a C. The new character facilitates sending email addresses by Morse code and is notable since it is the first official addition to the Morse set of characters since World War I, non-Latin extensions. For Chinese telegraph code is used to map Chinese characters to 4-digit codes and send these digits out using standard Morse code. Korean Morse code uses the SKATS mapping, originally developed to allow Korean to be typed on Western typewriters. SKATS maps Hangul characters to arbitrary letters of the Latin script and has no relationship to pronunciation in Korean. Unusual variants: during early World War I, Germany briefly experimented with dotty and dashy Morse, in essence adding a dot or a dash at the end of each Morse symbol. Each one was quickly broken by Allied SIGINT, and Standard Morse was restored by spring 1916. Only a small percentage of Western Front traffic was in dotty or dashy Morse during the entire war. In popular culture, this is mostly remembered in the book The Codebreakers by Khan and in the National Archives of the UK and Australia. Khan-cited sources come from the popular press and wireless magazines of the time. Other forms of fractional Morse or fractionated Morse have emerged. Alternative display of more common characters in International Morse code. Some methods of teaching or learning Morse code use the dichotomic search table below. Decoding software: it is possible to decode Morse code using software. The variety ranges from wideband software-defined radio receivers coupled to the reverse beacon network, where a software for the Windows operating system decodes a bunch of signals at once and detects CQ messages on ham bands, to mobile apps. See also, ACP-131, Chinese Telegraph Code, the CW Operators Club, Guglielmo Marconi, High-Speed Telegraphy, Hog Morse, Instructograph, List of International Common Standards, Morse code abbreviations, Morse code mnemonics, NATO phonetic alphabet, Russian Morse code, Tapcode, Weiban code, wireless telegraphy, references. Burns, R.W., Communications, An International History of the Formative Years, Institution of Electrical Engineers, ISBN A0-86341-327-7. External links: Morse code at DMOZ, Everyone Knows Morse at TV Tropes. Includes a list of uses and appearances of Morse code in movies, television episodes, and other popular culture. Morse code resources: International Morse code, hand-sending U.S. Army training video 1966. Morse code radio operator training technique of hand-sending U.S. Navy 1944.